Welcome, everybody, to this episode of Production ESP32. I wanted to share something that I'm working on, which is the Production ESP32 Playground project on GitHub. I'll just show that really quick. You can just get that from deploythefleet/prod_ESP32_playground. I will put a link in the description, but this is just a place that I'm doing research and development on Production ESP32 things, features of the chipsets and the IDF, and building some tools to go along with it. And the first one that I want to show you today is the integration with QEMU. And so I'm here in the repository, and there's a couple of things to notice. First of all, we've got a custom prompt here, which shows the user that we're logged in as. This is all in a Docker dev container, which I highly recommend. And then the folder that we're in. In this case, that's QEMU with debug. And I'm putting all of the examples and projects that I'm working on in the examples folder like this. And then right here, it shows the chip, the active chip that we're using, the IDF target. And there's a nice built-in alias here in this environment when you're in the dev container that I've created, which is called setChip. So we just type that and hit enter, and you'll see it gives us all of the valid ESP32 targets that we can select. And that way we can work with different development boards and chipsets right here within a single environment. And so I'm going to go ahead and hit Q to quit and leave that as it is, set to the ESP32S3. Now, you can see I'm in this example, QEMU with debug. I'm trying to put a README in each of these to show kind of what I played around with and messed with, just as a resource for the community. So let's come over here to main.cpp. It's pretty simple. There's an at main. We're grabbing the chip info and printing it out, and then just looping through this is QEMU. And so what I'm going to do is I'm going to make sure I'm in a perfectly clean build environment. idf.py full clean. And you'll notice I have access to idf.py tools right from the command line. This is all default, again, based on the Docker container that this environment builds for you. Okay, and what I want to do is I want to step debug this project. And so I'm going to put a breakpoint there right at the printf. This is QEMU. And we're going to debug it. Now, how would we step debug this? Again, I have no hardware. This is all going to be an emulation. Well, again, because of this environment that I have set up, I can just come over to the native debug tab here in VS Code, and I've got a QEMU configuration. And all I have to do is hit the play button here, and you'll see that it launches up GDB. All of this is handled for you out of the box. And once that's up and going, it'll launch, and you'll see that it gets to a breakpoint. Now, sometimes you'll see this where the breakpoint gets a little off, but it is indeed breaking at the point that I put the breakpoint. You'll see that the chip model is ESP32S3, and I can just step debug here. So if I step, you'll see that it prints this is QEMU, and I can hit play. It's going to go through again, and it'll just step debug as normal. When you're done, you can just hit the stop there, and it will clean itself up for you, which is pretty cool. So now let's go ahead and do an idf.py full clean. And what we're going to do is we're going to say set chip, and we're going to change it from the S3 to the ESP32, just the base chip. Now you'll see what happened there is it changed my prompt to just let me know, give me a visual indicator that I'm using ESP32 now instead of ESP32S3. And I can do the exact same thing. I still have my breakpoint set right here. And all I have to do is hit debug. Everything will launch for me again. And we should hit that exact same breakpoint. And we do. And you can see now the chip model is just ESP32. It's not ESP32S3 anymore. Same thing, I can step debug. I can remove the breakpoint and then just hit play, and it'll just go, go, go. While I'm running, I can also hit pause, and you'll see it's going to drop me somewhere down in here in the threads running. You'll see that I have debug about call stack for both cores over here, which is pretty interesting. And so I'm going to go ahead and hit stop there to clean that up. All right, and what's really nice, the way I have this set up is that we can support the only 3 targets supported for QEMU on the ESP32 are the ESP32, the S3, and the C3. But the C3 is a RISC-V chip. It is not an Extensa chip. So what I'm going to do is I'm going to say set chip, and I'm going to set it to the ESP32C3, and you'll see the prompt updated accordingly. I want to make sure I always do a full clean because it's built for the wrong chip architecture at this point. And I'm going to go ahead and hit clear. And let me go ahead and turn off my notifications so that doesn't bother us again. All right. Okay, so I've cleaned that, and now I'm running C3. Let's put a breakpoint here again, the same line. And again, all I have to do is hit the debug like I normally would. Okay, and now you'll notice a couple of important differences. The model obviously is ESP32C3, so that's emulating correctly. It did hit our breakpoint, so I can step here, and it'll say this is QEMU. You'll notice I only have one call stack now because this is a single core device. And so that's all working. And then you can see also we have all the things we'd have in a great debugger. We've got the local information here, the chip info that we defined up here at the top, and we can see the model. It's nice that it even interpolates that for us. Features, revision, cores, as you can see, is now 1. And so that's just a way that you can get up and going really quickly with QEMU step debugging without hardware. So you can play around with ESP32 and IDF without having any hardware whatsoever. And then one last thing I want to show you before we end this episode is I've shown you the set chip alias that I have in this environment. But now what I want to do is show you is we're in this QEMU with debug example project, as you can see here. But let's change into something different, like the minimal build project. This is just something I set up to show how you can set the minimal build property. And so let's cd over to that into the minimal build folder. And let's close this main.cpp and open up the minimal build one. You can see it's much simpler. I don't print out the chipset or anything, but it says, hello, minimal build. I forgot the D. Let's fix that. There we go. Okay, and so now if we want to step debug this, as long as we don't have any features that the QEMU emulator can't handle, like it's not going to do Wi-Fi or Bluetooth or things like that. But in this example, everything's very simple. It's just printf and sleeping. We can debug this in QEMU, again, without actual hardware. And so now that I'm in this, all I have to do is say debug this. And what that's doing behind the scene is setting up all the settings in the environment to now point that native debugger to this project instead of the other project. Now, I'm still using the ESP32C3 as the target, which should be just fine. I'm going to do idf.py full clean again to make sure that had I built this previously for a different architecture, we're now going to build it for the C3, which the debug will handle for you automatically. You notice I'm not building here. I'm just hitting debug, but the debugger is handling the build for us as part of this process. So it's going to go ahead and go through that. And now I'm in a completely separate project within the repo, and you'll see that I'm step debugging here again, nothing printing out. I step once, and you'll see hello minimal build. So that's it for this episode. I just wanted to show you how that works in this project that I've put together. I'm going to be adding a bunch of examples and things as I play around with features of the IDF and sharing that with the community so you can get up and going just as quickly. Thanks so much and have a great day.